Hey guys, welcome to lecture series on Fourier transform, which is from M3 subject. Already I have started lecture series based on the Fourier sine, cosine and their inverse transform. So if you are interested to see this video, go and check in my playlist. You can check in my I button also of here. Okay, yes. So in our today's video, I'm gonna explain to you all find the Fourier transform. Okay, Fourier sine and cosine transform for the following function. Okay. So we are taking two of these together over here. Okay, so at one time we are getting the practice for Fourier cosine transform as well as Fourier sine transform. Okay, yes. So let's get dive into today's lecture. I'm going to explain to you all Fourier sine and cosine transform for the function f of x which is equal to 1 when x which is between 0 and 1, and f of x which is equal to 0 when x is strictly greater 1. Okay, yes. First of all, we go for finding the Fourier sine transform. Okay, and as we all are familiar with the Fourier sine transform, let me write the formula. Fourier sine transform. Let me write the formula for Fourier sine transform. Okay, so Fourier sine transform it defined as, okay, Fourier sine transform defined as Fourier sine f suffix s. Okay, whenever suffix s means we denote as a Fourier sine. Okay, transform over lambda. Okay, Fourier sine transform over lambda. We write this one as a integral over 0 to infinity. Okay, integral over 0 to infinity small f of x. Okay, small f of x sine lambda x dx. Okay, sine lambda x dx. It is completely up to you all guys. So sometimes we get writing yes, we writing lambda. Okay, not to get confused with this notation. This is just these are the just notation. Okay, yes. So Fourier sine transform over lambda can be written as 0 to infinity f of x sine lambda x dx. Okay, yes. So we have to define the function. So as we have given piecewise function, one piece is 1, another one is a 0 for this specific interval. Okay, so let me define this interval over real line so you can understand where to break this integral. Okay, yes. So here I do have real line over here. Okay, so 0 it is here, minus infinity, plus infinity. Okay, so whenever we have value 1, okay, whenever we have x between 0 to 1, whenever x which is between 0 to 1, okay, so consider 1 it is here. Okay, whenever x between 0 to 1, we take f of x is 1. Okay, so what we take f of x which is equal to 1. Okay, whenever x it is between 0 to 1, we take f of x which is equal to 1 over here. Okay, yes. And whenever x it is bigger than 1, okay, x greater than 1, we take f of x is a 0. F of x we consider it as the 0. Okay, yes. So we have two function. It is for interval 0 to 1 it is 1 here, and bigger than 1 it is a 0 over here. Okay, yes. So we are going to break this integral for Fourier sine transform with a 0 to 1 and 1 to infinity. Okay, so 0 to 1 f of x and 1 to infinity f of x. Okay, let me write Fourier. Okay, let me write this function Fourier. Okay, sine transform over lambda, okay, can be broken into the two intervals 0 to 1. Okay, 0 to 1 small f of x sine lambda x. Okay, small f of x sine lambda x dx. Okay, plus integral over, okay, 1 to infinity. Okay, 1 to infinity. So we have two interval. So I made here we have given two pieces of the interval 0 to 1 and 1 to infinity. So 1 to infinity small f of x, small f of x sine lambda x dx, sine lambda x dx. Okay, now see that I have these two pieces of the integral over here. Okay, yes. So just go for the replacement of values. Okay, so whenever interval 0 to 1, we take consider f of x is a 1 here, f of x is a 1 for this interval. Okay, so replace f of x 1 here, 0 to 1 into sine lambda x dx. Okay, so this one is a Fourier sine transform over lambda. Okay, yes, plus integral 1 to infinity. Okay, so small f of x, whenever interval we have 1 to infinity, 1 goes to all the way up to the plus infinity, so we write f of x is a 0. So whenever interval all the way 1 to onward, okay, 1 to infinity, we consider this integral as a f of x as a 0. Okay, so if this one is a 0 into sine lambda x dx, okay, we consider this 0 into sine lambda x dx. Okay, yes. Now see that 0 into this function obviously gives us the value 0, so we don't have to worry about this one. Okay, Fourier sine transform over lambda. Okay, we write 0 to 1, 1 into sine lambda x, it is only sine lambda x dx. Okay, plus, okay, so 0 into integration, 0 into sine lambda x is 0, and 0 has integration 0, and 0 keep as it is here. Okay, so we got this entire integral 0. Okay, Fourier sine transform over lambda. Sine lambda x has the integration. Okay, sine x has the integration minus cos lambda x. Okay, minus cos lambda x. Sine lambda x has the integration minus cos lambda x, and as it is a composite function, so we are taking differentiation of a lambda x at the denominator with respect to x, so we lambda remain here. Okay, bracket complete. Okay, integral over 0 to 1 here. Okay, yes. So first of all, substitute x as 1. Now see that here we have to substitute 1 and 0. Figure it out by using integral. Okay, so integral with respect to dx, that means you have to replace x as 1 and x as a 0. Okay, so minus cos lambda into 1. Okay, minus cos lambda into 1. Okay, divided by lambda, minus cos lambda into 1 divided by lambda, minus, okay, so minus this between we take a negative sign, minus again that minus sign out here, cos lambda into 0, so cos 0, okay, cos 0 upon lambda. Okay, this one, so minus minus gives us the value plus. Okay, so minus cos, okay, minus cos lambda divided by lambda, minus cos lambda divided by lambda, minus minus gives us the value plus, cos 0 it is 1 upon lambda. Okay, okay, so this one is our required Fourier sine transform over lambda. Okay, so I hope you all have understood how I have written this solution. For your reference, you can refer my this example over here. Okay, this one is the example, it's a Fourier sine transform, I found it here. Okay, yes, I hope you all have understood this Fourier sine transform. Okay, don't go anywhere guys, we have Fourier cosine transform still it is remaining. Okay, so let's get to the Fourier cosine transform now. So for Fourier cosine transform, we go for finding Fourier cosine transform and Fourier cosine transform over lambda. Okay, Fourier cosine transform over lambda, it can be written as integral over 0 to infinity. Okay, small f of x, small f of x, as it is a Fourier cosine transform, we take cos lambda x. Okay, we take cos lambda x dx. Okay, yes, this one is the our given Fourier cosine transform formula. Okay, yes, we are going to apply here for finding the integral. Yes, as we have explained, as I have explained, we have piecewise function for f of x is 1 and f of x is 0. Okay, so when we have interval 0 to 1, so I'm going to write this interval directly over here. The explanation I already given in my last lecture. Okay, so not last lecture, last part, that means for Fourier sine transform. So I'm going to break this into integral only 0 to 1 small f of x cos lambda x dx. Okay, plus integral 1 to infinity f of x cos lambda x dx. Okay, I have broken this integral. Okay, so how I have broken, if you want to see guys, you can check it here. Okay, so as we have piecewise function 0 to 1 and 1 to infinity, so as we have done it here in our Fourier sine transform, as we have similarly we have to take it to the Fourier cosine transform over here. Okay, yes, need to replace similar values over here guys. Okay, so whenever we have integral 0 to 1, we take f of x as a 1 cos lambda x dx. Okay, yes, and plus whenever we have integral 1 to infinity, we consider integral f of x as a 0. So f of x 0, that means cos lambda x 0, that means entire integral gives us the value 0. Okay, so Fourier cosine transform over lambda can be written as integral over 0 to 1 cos lambda x dx. Okay, so go for finding the integral only. Okay, so cos lambda x has an integration sine lambda x. Okay, and differentiation of a lambda x, it is only lambda here. Okay, and integral over 0 to 1. Okay, yes, so put the values over here. First go for the 1, then go for the 0. Sine lambda into 1 by lambda, so which is a sine lambda divided by lambda. Okay, sine lambda by lambda minus sine 0 by lambda. Okay, sine 0 is a 0 and 0 by lambda means only 0. Okay, so we have Fourier cosine transform over lambda. Okay, we have Fourier cosine transform over lambda, which is a sine lambda divided by lambda. Okay, yes, so this one is our required Fourier cosine transform. Okay, I hope you all have understood, guys. It is one of the easy solution, and such examples are coming for your SPPU question paper for like 4 marks, 3 marks, sometimes 5 marks also. So don't forget such a easy questions. Okay, this will give you a good and out of marks. Okay, so I hope you all have understood my entire solution for Fourier cosine and sine transform. I combine both of the example over here. Okay, so that we get the practice for Fourier cosine transform, Fourier sine transform also. And I explained inverse transform example in my playlist, guys. So if you are interested to see this video, do check in my playlist. Okay, so that's it for my today's lecture, guys. So it is really time taking to record one video, but for you all I'm taking efforts. So I hope you all have understood. Okay, and even after, if you found anything difficult, guys, let me know in my comment section. I will come up with a similar video. So thank you everyone, thank you for my today's lecture.